8-9, we're talking about graphing inequalities, which are very similar, but not the same as graphing equations. So there's another lesson, so I would imagine there's something new, but there's a lot that we're doing the same. Okay, what I want you guys to do is on your regular notebook lined paper, we're going to try out another graph as review, and then I'm going to use that graph to help us with the next lesson. So please graph, to start off with, graph y equals 2x minus 3, please. And I'll give you just a little bit, well, I'll give you a couple minutes to do that. Graph that equation on a coordinate plane and be neat and be careful and try to draw as straight as you can. I know you don't have to be perfect, but the quicker you are, the worse it gets. That's unfortunately how it works. Yep.
How many points would you like us to put on the
fill it up. So like whatever it takes to fill up the graph wherever it's at. Negative 3. Jack?
I'm not confused on what to do with like the 2x, because I can get like negative 3.
Okay, you got that point?
Yes, sir.
So this is a slope of 2 over 1. So the rise is 2, the run is 1. And hopefully that can get you those. Yeah, if it's a whole number slope, like 2, you can put it 2 over 1. And hopefully that is enough to help you out. Okay, how many of your graphs look similar? It doesn't have to be exactly the same because maybe a bit bigger, wider, taller, but you look like that. Okay, good. Now, what I want you to realize is that these problems can all be checked. Remember how I told you like equations can be checked? So can graphs. Does anyone remember how to check it? How can I check this and make sure it's correct? John, what do you think?
You take one of the order pairs.
Okay, we're going to go with this.
2, 1.
You want to go with 2, 1? John and his section. So this section here, we'll use 2, 1. Sydney, what other point could I use? Okay, this point right here, 3, 3. Sydney and her section will choose 3, 3. And Braden, what other point could you use?
1, negative
1, negative 1. Braden and his group will use 1 and negative 1. What I want you to do, whatever your point is put the x here, put the y there, and see if it makes it true or not. If it makes it true, you're good. If it makes it false, either you graphed it wrong or you checked it wrong. Which you put this x value, 3, 2, or 1, right here. So it's going to be multiplied by 2, and then that should get you your y value when you work that out. So I'm going to pick, I'll use the 3, 3. So I would say 3 equals 2 times 3 minus 3. Oh, man. What's 2 times 3?
6.
Minus 3?
3.
That works. So 3, 3 works. Who was the 2, 1 section? Okay, does it work?
Yes.
Yes. Do you have a question, Jack? Or okay. Who was the 1, negative 1 section? Did it work?
Yes.
Yes. Any points on this line would make this correct. You guys okay with that?
Yes.
Okay, that's how you check these graphs. You can check 1, maybe 2, and then you're like, yes, I got it. Or, ooh, wait, that can't be it. I would not check the one on the y-axis because most of you can get that anyway. Check any other point not on the y-axis just because you could get that one right, but then another one wrong, and you thought you got it right. Yes, Brady? Is it an emergency?
Yes.
Okay, go. All right. Now what I want you to do is graph this one. This is what the lesson's about. Oops. What's different about this problem and the last one we just did? One critical, but very major difference. Caroline?
It's not an equation because there's no equal sign.
Oh, that's why they call it inequalities. Okay, I get that. But how do I graph that? You graph it just like you would an equation that has an equal sign right here. Same thing. I want you to draw another one that looks exactly like that. Yes. Your checking's different, then you're going to find out the answers are actually different. So just graph it. How about this? Go ahead and graph it. And I know it's the same thing, so hopefully you can get this one right. Yay? Yeah, good. I hope you get it. Okay. That's what I get, but that's not the answer. It can't be the answer. How do I know it can't be the answer? What did I do at the end of my first problem to make sure it was correct? Michael, you checked it. Give me a point on that line. Okay, -1, 1, right here. Or sorry, 1, -1. 1, -1. All right, are we good on that? I'm going to check it. Ready? So here we have -1 is greater than 2 times 1 minus 3. All right, what's 2 times 1? 2 minus 3? -1. Is -1 greater than -1?
No.
What? Uh-oh. Okay, what you're doing on these inequality graphs are the same thing you did with the equations, but instead I need to draw the line a little bit different. Your points are still there, but this is what you need to do. Ready? And you can do this if you have an eraser, or you can erase. Hopefully you have an easy way. It's a dashed line. Dashed line. So just do that, and then I'll explain the reason why it's dashed. I mean, wait, what? Dashed? I'll explain it, because there's a reason behind it. It may be cool, may not be. No, I think it's a cool reason. And you've already done this before, by the way. Wait, not me. Wait, no, that was 8th grade. No, that was you guys. No, it was you guys. Not too long ago. Okay, and I just realized that, is that point a solution? Was that point, 1, -1, a solution to this inequality? No. Is this point a solution? No. Neither is that point. But there are solutions. Ready? Look carefully here. You see this greater than symbol? What does greater than mean? It means bigger or above or greater than, like what we normally think. It's not this line itself. It's all the points that are represented above the line. I'm shading this whole region right here. All these points in this graph will make that true. All of them. So shade it for me, please. Everything. Like I'm talking, you see this line? Shade it. Yeah. Darken it. That whole region is my solution. And how many solutions are there then? Infinite. Yes, then you get to love this. Watch, guys. What I'm trying to say is that every point that's represented in this region is a solution. And you're like, how can you say that? Let's just go with an easy one. Isn't this 0, 0? Yes. And according to me and my graph, that should be a solution, right? Okay, let's see. Does 0, 0 work? What's 2 times 0?
0.
0 minus 3?
-3.
Is 0 greater than -3?
Yes.
That works. You know what? Every single point in here works. This is what I want you to do because you know what? Don't just take what I say if you're doubting it. I need every single one of you, without communicating with each other, to pick a point in this shaded region. Pick any point. So don't make it too hard on yourself. Maybe, and I'm not saying who's picking this, maybe pick this point, or this point, or that point, or this point, or this point. Okay, just pick a point. Get the ordered pair. So pick any point in that region. So you can go like -1, +2, 0, 5. I don't know. Pick a point and check if it works. So pick any point and check if it works.
You know when you substitute like the numbers in the order pair for the x and the y when you're
Yes.
checking it, you switch those?
Well, isn't this number right here the x value? And the y is, so yeah, it is kind of switched, but they go where they belong. Yeah, so be careful. Don't put x first, then y, because that first value should be a y. So that's how you can check it. Pick any point. Okay, I'm going to ask several of you, and I'm not going to see if you checked it. I'm just going to ask what point you picked. Josie, what point did you pick?
I picked -1, 0.
So this one right here. Okay, Marissa, what did you pick?
I put -1, -1.
Okay, she picked this point. Michael? -3, 1. Timothy, what did you pick?
-1, +2.
Okay, right here. Elizabeth, what did you pick?
-6, 2.
-6, 2. You mean way out here? Oh, man. I didn't shade that region. Emma Grace?
-2, 2.
-2, 2. Okay, so you pick that one. Mackenzie, what did you pick?
I picked -2, 0.
-2, 0. Okay, and some of you may have picked similar ones or ones around here. Did they check?
Yes. I picked
If you did it right, they will check. So if they didn't check, something happened. Did anyone check it and it didn't work? Okay, what was your point?
-1, -1. But I think I did it right.
Yeah, and I'm just going to clarify it. -1, -1?
Yes.
What's 2 times -1?
-2.
-2 minus 3? -5?
Okay.
And then -1 is greater than -5. Okay, that's okay. But you see all of them check? Okay, ready guys? Do you see this region below the line?
those don't check.
None of them should work.
Are you sure? Can we try?
Pick a point. Anywhere out here that's outside of that shaded region cannot work.
It is the wild.
Oh, I saw, yeah. Yes, ma'am?
If it's a negative, would it be on the other side of these? It's like a negative slope.
Oh, yeah. So here's how I determine it. Do you guys see my line? Okay, what would be above the line? Would it be the region to the left or to the right? What's above the line? To the left. But if it were flipped, the region above would be the right side. It just depends on where it's slanted, and always think greater than means above, less than means below. So yeah, that's a good question. Okay, Jensen, what point did you pick out here? That's okay, you can pick right now.
5, 4.
Somewhere out here. Okay, check it, please. Sophie.
3,
-3,
-3.
-3. Right here. JB, did you pick a point? +3, 0. Good. Jack?
8, 0.
8, 0. So somewhere out there. Braden?
8, 10.
8, 10. And that one actually, I'm not sure, but you could,
8, -10.
yeah, 8, -10 will work down here.
Oh,
8, 10. Do you see how I'm not super sure because that line could get to that point, but yeah, 8, -10 won't. Okay, check them.
I don't know
What I put 3,
Looks like a
I think I
paintball,
messed up.
like-
What point did you use?
I did 2, -4.
So 2, -4. So down here, okay, that should work. Or excuse me, that should make it false. Okay, 2, -4, right? What's 2 times 2?
4.
4 minus 3? Is -4 greater than 1? Nope, doesn't work. That's good. It's not supposed to work. Yeah, it's not supposed to work. Right, because none of that was shaded. Do you guys see where these answers come from? Like, do you see how that should be good and that should not be good? Okay, and anything on the line should also not work. That's interesting. And I'll tell you why in just a moment. Yes, sir. Timothy?
On the line, is that counted as greater than or less than?
On the line is counted as equal to.
That's not my actual question. Well, actually, as the next question, I was going to ask, how would you get it equal?
We're going to do another one that's that. All right, listen to me, guys. Listen to me. These are important notes I'm giving you right now as a key to help you to understand, well, how do I graph this? Okay, if you have a greater than or equal to or a greater than sign, that means above the line. Above the line. Always. If it's a less than and equal to or less than sign, that means, anyone? Yes, below the line. You guys okay over there?
Yes.
So does it make sense? Greater than means above the line, less than means below the line? So this is something you must get down. If you don't get this, it's going to be really bad. That's what I'm talking about, shading. So you see how I have a greater than symbol? So where should I shade? Above the line. So that's how I did that. So please write that down because that's critical to this lesson. And you can always check it. You can always see, Mr. A, did my region work? Well, pick a point in there. Yes, it does work. And you can pick a point in the region that doesn't work, and it doesn't work. That's good.
If it does work in the region where you put it, then, or doesn't work in the region where you said it should work, then don't you switch the region?
Possibly. Check to see if you did it right, then shade it, and maybe pick another point. So you can check multiple times, like really nail it down. Okay, let's look at example 1. This one's different. Does anyone notice what's the difference on this one and the last one? Y is
Greater than.
less than or equal to -2x plus 2.
Wait, it doesn't say that.
Oh, yes, time out. Thank you, John. I'm making it say that today because they didn't give us an example with the equal to sign. So yeah, example number 1, I'm making it say less than or equal to. Do you understand? I'm putting that in there. Thank you. Because I want us to get practice with this one. Okay, how do you start this graph? All you do is start it as if it had an equal sign. So how would you graph y equals -2x plus 2? That's all you're trying to do. Okay, where would I start this graph? Just imagine it had an equal to sign, no inequality. Mackenzie?
Oh, I don't know.
You want to try? Where would you start this graph?
Like,
On the y-axis, so right here. Right there. Start my graph right there. And Bella, where would I go from there?
you go down 2
And then?
over 1.
Good. Down 2 over 1. Down 2 over 1. Wait, that's going to be a negative slope. That's going to be a negative relationship. Is that accurate? Yes. So please check that on your own. Okay, and I'll go up 2 over 1. And then I'm going to connect the lines. Remember how last time I used a dash line? This time I'm going to use a solid line. Does anyone know why I would do that? Michael? Because it has equal to. I said you've done this before, and I wasn't joking around. The last line was similar to the open circles. Do you remember open circles on a number line? And the equal to, or the solid line, is like a closed circle. So have you done that before?
Yes.
Yes. Many times, I hope. If you got them right. Okay, so I'm going to put a little note before I finish this up. If you have greater than or less than, that's what we call a dashed line. That's the type of line you're going to shade in. If you have a greater than or equal to or a less than or equal to, that is a solid line. You guys see what I'm saying here? So there are really two big pieces of info I really need to get to graph these inequalities. So if it's less than or greater than, it's a dash line. You got to make those little dashes. If it's greater than or equal to or less than or equal to, you need to have what kind of line? Solid. So what kind of line must I have here? Solid, because it's a closed circle. It's like, and I'll tell you what that means on this line. Can anyone kind of guess? The last problem, did the points on the line count? Did the points on the line make that inequality true?
Well, on this one it does.
On this one it will, because it's a closed circle. It includes the line itself. Okay, less than or equal to, less than. What region should I shade? Less than. I should shade the region that is below the line, which in this case is going to be on the left, so right here. You guys see that's below the line? I always wonder if maybe I'm just seeing it a certain way, but are you guys in agreement that this is below the line?
Yes.
I'm not telling you left and right. I'm not saying go left, go right. I'm telling you below and above because it depends on what slope it has, whether you go left or right. I'm talking below the line. Okay, yeah, go ahead. Look at it and tell me, because you're probably thinking, well, can't that, you see it?
Yeah.
I think
Because if you go all the way across,
you're going to get this giant line, and you're like, what's below it? Well, it's going to be this region right here. What's above it? It's going to be the top region. We'll do the slope dance later. Okay, Michael.
Why we should work on that?
Because it says less than. Mm-hmm.
What about if it says greater than?
If it says greater than, you shade above the line. Yes, ma'am?
I still don't get above and below.
Okay, do you get where it says less than? That means what? According to your notes on the last page. Below the line? If it was greater than or equal to, you shade above the line.
I know, but I still don't understand if I were to look at it, which is above.
Good question. So maybe this little, okay. This is your line. Point to the region above this line. Right? Okay, sorry, I'll point it like this so you guys can. What's above the line? Point to it.
right.
Yeah, to your right here. And below line's down here. Now ready? I'm going to make it a little bit tougher. What's above the line? Okay, ready? I'm going to make it a little bit tougher. Ready? What's above the line?
To the right.
Above the line. Above the line. Above the line?
Perfectly.
It's still this way.
It's not centered.
Above the line, think on the x-axis, don't the numbers get bigger this way? So if you have a vertical line, this is above this. I'm not giving you a vertical line. Okay, ready? What about this? Below the line.
Down there.
Below the line.
Over there. Over there.
Below the line's, yeah, right here. It takes time, but I think if you really think about it, really look at it, you're like, what's above and below? You'll be able to figure it out. Okay. But yeah, I don't know if it's just kind of hard to read. Okay, this is what I want you to do.
You're still holding it.
But I can walk better. Oh, Swivl.
Hi, Max.
You know, Swivl doesn't like me going this way because he gets stuck. Sorry, Swivl. I think he needs a grease. Okay, guys, can you listen to me? Should this point right here work?
Yes.
Okay, 0, 0 is always a nice point to pick. Does 0, 0 work? What's negative 2 times 0?
0.
0 plus 2? Is 0 less than or equal to 2?
Yes.
And then this point should work or not work? Right here, not work. And that's going to be 2, 0. So if I put 2 here instead, what's negative 2 times 2? Negative 2 times 2? Negative 4 plus 2? Is 0 less than or equal to negative 2? No, that's why that's not part of the answer. So it makes sense. Yes, ma'am.
For the homework, are we going to have to check it?
I would, but I'm actually going to give you your homework right now. listen carefully. I'm going to give you what you do on each section before I give you your homework, because I want you to pay attention so that you're not confused when it comes to the problems. I hope you're not confused. Yes, sir. Does it?
How do you actually write?
Sorry?
Do you just like put it and then like shade it in?
Yeah, just shade it. Yeah, you just kind of color it in. There's no like set way. Okay, look at page 421. This is your homework. Ready, guys? Let me explain the homework, then I'll give the homework, then I'll get those questions. Yes, I'll give you graph paper, but don't start working now, because I'm telling you right what to do. Look at numbers 19 to 24. Determine which ordered pairs, comma, S, that means it could be a pair or pairs, is a solution to the inequality. On 19, how in the world do you know if A is an ordered pair in that inequality? What do?
You replace x and y with -2.
Yes, and do that carefully. So you just have to replace x with -2 on A and y with 2 and see if it works out. If it works, that's an answer. And check A, B, and C. Some of them have one answer, some of them have 3. Okay. Yes, sir. Max?
So for that part, we don't have to do anything on the graph.
No, you're not doing anything on the graph yet. And even 25 and 27, guys, I'm not going to repeat myself here, and I really don't want you to be confused. On 25 and 27, they already drew you the graph. All you have to do is on your paper, sketch it out. When I mean sketch, you're just doing this. Just like this, and then draw the graph slightly, as best you can. Something like that. And then all they want you to do is tell me what shade the region that you're supposed to do, above it or below it. You do that on 20. Same thing, above or below the line, it tells you y is greater than. So you know that means above the line. John?
On number 26,
Braden? Face the front.
they have a graph for it, but it's not a solid line, even though it's...
Yeah, I think it's a typo. I think you were supposed to darken it if you had 26. Good observation. 28 through 43, those you have to graph. Give me a shaded region and give me the correct type of line. That's where you're doing all that we did up here. You guys understand that? You're going to have to graph it with the correct type of line and the correct region that's shaded. That's for 23 to 40.
Do we have to graph from 19 to 24?
Okay, your homework tonight is 19 to 35 odd. So I did tell them what to do on those. That's okay. It's just I do want you guys to pay attention. 19 to 35 odd. And then 53 to 55, some review problems. Page 421 to 422.